Howdy folks, welcome back for another Feature Friday. I'm your host Ryan Glover, and this week we're going to be jumping into part 3 of wiring up our integration to GitHub. So in the past 2 episodes of Feature Friday, we've been walking through how to wire up just an integration to a third-party service, and GitHub has just been the example case. And what we're doing is we're wiring up these integrations inside of Command, the upcoming SaaS product from Clever Beagle. So what we're going to do today is pick up where we left off last time, which is back here in the UI where we were actually trying to configure the integration. So up until now, I've walked you through the process of connecting to GitHub via OAuth. So that's connecting to our third-party service as one of our own users who wants to grant us, the application, or in this case Command, grant us permission to get access to their account so that we can perform tasks on that third-party app as that user. So we've gone through that process of connecting to the user's account, and then last week what we were doing is focusing on, well, how do we actually manage or configure the integration? And so what we talked about was, in the case of this GitHub integration, we needed to go up to GitHub's API and say, hey, you have to tell us which repositories does this customer have, and then from there were other pieces of configuration on our side internally inside of Command that we needed to configure as well. And so what we're going to look at today, so now that we have all the information we need to actually do the configuration, or to save the configuration is a better way to think about it. Now that we have all of that information, what I'm going to do is walk you through the process of actually saving it to the database. And that may sound simple. Part of it is simple, part of it is a little more difficult. So we're going to step through all of those pieces, starting down on the client where we left off last time, and then moving back toward the server, to the GraphQL server, and then over to the GitHub API to do some interactions there. So what we've got up in front of us is the configure GitHub integration modal. So we've already gone through the process of connecting to GitHub, and when we click on that gear icon, we get the configure integration. And let me go ahead and reload this so you can remember here. So what we do is we connect our account, and then we click this, and you'll remember that we have to go to GitHub to tell us, well, what are the branches what are the repositories and what are the branches that the current user that we've authenticated as has access to. And so once we have that information, then we can start to build the actual configuration for this integration in our database. So what we've got up to this point is we know that, okay, this user has access to all of these different repos. And you'll notice down here I'm selecting this test one I've set up intentionally for this tutorial. And so what we've got is we're selecting our repo, and then we get all the branches that are available on that repo. So you can see I've got my master branch like we'd expect, and then I created a dummy one called turkeys just so we can play with this. And so at this point, up until now, the only thing that I've taught you is just getting the information into this modal, but not actually pushing it back to a database. So what we're going to do is jump into the code, and right here, this is where we left off last time. So what we were doing is saying, okay, after you've changed a branch, we're going to set that branch onto state so that it appears correctly in this box. But then the other thing that we're going to do at the same time is, you'll notice I'm saying has change is true, and I'm setting this as a value on state. And this has a purpose, and it's going to become more clear toward the end of this video. But the point of this is that when we go to save this integration, we're potentially going to be making a request out to GitHub to add a webhook onto the user's account. And what that means is that we have to keep in mind, okay, this user may already have this webhook enabled, meaning we don't want to try and set it again. And the reason why is that GitHub is going to throw an error back to us. They're going to say, wait a minute, you've already done this. There's no point to this. And so what we need to do is guard against that. And so that's what has changes is up to. It's allowing us to say, okay, and let's take a look. So we got to pay attention here. In the browser, if I click configure GitHub, you'll notice that when this loads, save integration is not clickable. So that's what has changes is helping us to prevent. So if that state value is false, this button is disabled automatically. So you can't even change the integration unless you've actually changed it. And what that means is changing something like the repo. So we'll say we've got Robin Williams 45. So if I switch to that, you'll notice that it switches and then the button is enabled. So at that point, what that's communicating back to us in the code is saying, hey, there's actually something to change which means that if we go and send a request to GitHub, we're not going to get an error because we're actually changing something from what we already have. So that's the essence of what that is. And again, that'll come more into focus as we get to the server side of this and walk through actually sending requests to GitHub. So once we've done all of that, so we'll say that we've made changes as a user. I've kind of said, and let's go back to my test one here. So we'll say test GitHub webhooks, and I don't know, we'll be watching the turkeys branch. And the thing to keep in mind that's important here is that really the only thing we care about in relation to GitHub is the repo. So the branch is just for us internally, which basically says if they've selected this branch, we're only going to actually record data that's sent to us via the webhook for that branch. So we're going to get, no matter what we do, once we create this webhook, we're going to get all of the events that are coming from this repository, no matter what we do. And so on our side, internally in the application, we have to limit or filter what's coming in to say, hey, only limit it to this branch. Don't give us anything else. So with all of that, what we're doing is handle save integration is the function that's called when we click save integration. And so once we get into there, then we're starting to move more over to the GraphQL side of things, or to writing to the database. And so what I'm doing here is, you'll notice I've got saving true. So the point of this is to tell ourselves that, hey, we're currently in the process of saving this. So this is very similar to this has changes flag. The difference being that while we're in the process of saving, or we're writing to the database and writing to GitHub, we want to disable that button so we don't get a bunch of double presses, because the process does take a little bit because we're doing so many hops. So we want to say like, don't let the user double click. We want to avoid that. So that's the very first thing we're doing here. We're saying on state set saving to true so that we can disable that button while we're waiting for a response from GitHub. And then the next thing is we're going to call to on save integration. And this is the name of our mutation. So if I jump down to the bottom of the file here, we can see that I've got my query. And actually, I'm showing you the wrong modal here. So if we go back up, let's make sure this is clear. That's right. So I've got on save integration is a prop being passed to this configure GitHub integration component, which you'll remember and this is exactly why I was a little fussy about this last week, is the way that I built this. It's you're nesting each network's integration configuration, or the form for configuring that integration, inside of a component that's nested inside of the actual modal, which is this configure integration modal. And so if we look down here, we can see that for each of the different types of integrations, we're going to render out that integration's form. And so what we'll notice is that when we render the configure GitHub integration component, what we're doing is setting the on save integration prop, in this case, which is set to a function. We're setting that to a function that's calling this.handle save integration and telling ourselves that the one that we're saving is GitHub. And again, the whole point of all of this was to try and consolidate this, or standardize this process of saving an integration regardless of what third party we were going out to. It's okay. I'm not sure I would recommend this pattern for everybody. It does work, but it's one of those things that's, I don't know, I'll probably come back and refactor this at some point. The important part, though, is that this.handle save integration, if we take a look at that, what we're doing in here is actually calling to our mutation. So now this is where we start to kind of diverge from the standardization process, because every single integration that we have is going to have different arguments and different data and different things that we're actually configuring. So, I might set a repository on the GitHub integration, but obviously I'm not going to do that for MailChimp. And trying to keep it dry is the favorite developer term. Trying to keep that process dry, not really worth it. So what I've done here is I've created separate mutations for each of the different third-party integrations that are being added to command. So what I've got here is update GitHub integration. And now if I jump to the bottom of this file, we can see I'm loading that mutation onto this component. And so if we jump to, let's see, we're looking for, so this is under the UI directory. So this is UI mutations. And I'm looking for products. There we go. And we've got the update GitHub integration mutation. So what we're doing here is we're passing the product ID. And remember, the important part here is that because you can have multiple products in command, and you might want to connect to different accounts, different third-party accounts for integrations to each of those products, this is set up so that we're only setting this integration on this one product in the database. So you could easily create a new product, connect to another account, and there's no issues. So that's the reason we're taking in product ID here. But then the important part, or the more obvious part, is that we're then going to take in all of the actual configuration data for this integration. So we've got our repo, we've got our branch, and then we've got our two true, false, or toggle questions, which are, do you want us to sync commit mentions on cards? And do you want to allow closes via commit messages? So meaning if somebody types closes number 32 and number 32 matches a card on this product, we'll close that card automatically for you without you having to manually come into command and click close card. Kind of nice. And same exact idea with sync commit mentions on cards. All we're doing there is saying if you mention that card number and we see it inside of your product, do you want us to log a mention of that inside of the activity stream for that card? So that's it. So with all of that, what we're doing is we're going to pass that up to our GitHub, update GitHub integration mutation on the server. And then what we're going to do is take in that data and actually update the integration. So one thing I do want to point out is, let me make sure I show you the right spot. Yeah, we want to be back here and update. Yeah. So this is back in the configure GitHub integration. Again, this is the component that's nested within configure integration modal. And so what we're doing here is we have to tell ourselves, okay, what repo are we trying to save, which branch, and then we also need our two toggle questions. So you'll notice that on the repo one, what I'm doing is I'm using this function that's built into pup. And again, pup is the boilerplate framework that I built for mentorship customers at Clever Beagle, but I'm also using to build this product. And this is free and MIT licensed, so you can go download a copy and build your own product with it as well. So Unfreeze Apollo cache value is one of the functions that's built into pup. And what that's doing is it's saying when we get some data out of Apollo, and Apollo is the client-side tool that we're using for making requests to GraphQL, but it's also storing the responses from GraphQL locally in the browser for us. So they have a client-side cache. And once the data is retrieved from the server and stored in that cache, it takes on an immutable state. And what that means is that all of the objects or all of the data in that cache is immutable, or you can't change it. So if we have a piece of data and we need to set a property on it, or we need to do anything else, we can't. It's just frozen. And so what this is doing is it's removing that frozen state. So it's saying, let's make this immutable object mutable. So that's step one of what it does. But then two, it removes the extra data or metadata that Apollo adds to each object that it downloads and puts in the cache. So if memory serves, it's underscore underscore type name telling you what the type of the data is that exists in the cache. And when we're sending that data back to the server, we don't want any of that extra stuff. And the reason why is we're not actually accounting for that inside of our schema or inside of our type definitions in our GraphQL schema. And so what this function is doing is it's stripping all of that out and just giving us back a plain object with just the properties that we expect to have. And so what we're doing here is we're saying, well, we know that we have a list of repos on state for the user, and we're trying to match that repo, or match in that list of repos the one that the user has selected. And so this may seem a little funky, but the reason I'm doing this is that in the database I store both the ID, so the unique ID of the repo on GitHub, as well as the name of it. And the reason why is that I use that name elsewhere in the UI, the name of the repo. I use that elsewhere in the UI, so I want to be able to just display that without having to make extra trips back to the GitHub API to get that information. So that's what's happening here. We're just saying, okay, we're going to set repo to an object with an ID and a name value, and this is how we're getting it. So we're saying on the state repos value, so the entire list of repos, find the one in that list that matches the ID, or the value in this case. So in this drop-down right here, the value of each of these options is the ID of the repo. So what we're saying is find that ID on one of the objects in the this.state.repos array, or in this case, the repo that we're trying to set this to. So once we've got all that, things get a little easier. Getting the branch value is pretty simple. All we care about is just what is the name of the branch. And then we've also got the toggle options. So we've got sync commit mentions on cards and allow close via commit. So with all of those batched up, the next thing we do is we send that up to the server. Now, before we go and look at that, let's just review this now, because this will make a little more sense in context now as opposed to coming back. So what's going on here is we're saying, okay, once that integration is saved, we're going to say if there was an error, obviously tell us about it, and we're going to set saving to false. But then down here we're going to say, okay, if everything goes as planned, what we want to do is go and refetch the data for this integration. So the reason we're doing that, and there's a few different ways to do this with Apollo. Technically, I could pass that data back to the mutation. The reason I like this version is that it's very definitive. I know that it's going and it's actually hitting the database in the exact same way that we would if we were loading this page up or loading this modal up for the first time. So potentially not the most efficient way to do things, but it gives me that certainty that this data is correctly synced with the database and I'm not giving myself an incorrect state, which is helpful in this case because dealing with the third party, you don't want anything out of sync. You want to be absolutely certain that, like, oh, okay, this is correct. So with all of that data refetched, then what we do is we just set saving to false and say, hey, your integration was updated. So what I don't do is close the modal. So let's go ahead and save this. We're going to say test GitHub webhooks, and we're going to say the branch is turkeys. So right there, we're in the saving state. Takes a few seconds, and then we see GitHub integration updated. And so at that point, you'll notice that has changes goes back to false. So we don't have any changes now. This is technically in sync with GitHub. And the other thing is that we're no longer saving. So we get our button from, instead of saying saving, back to save integration. So all of that said, now we're ready to jump up to the server and take a look at how all of that stuff is coming together. All right, so where I've moved us to here is in the api.js file, and this is where we define our entire schema for our GraphQL API. So, and you'll notice we've got our type defs, we've got our queries, and this should look fairly familiar. We've definitely talked about this before. But the part that we want to focus on is the mutation. So in this case down here, we've got update GitHub integration. So what this is doing is this is defining the actual potential for us to run this mutation from the client. So we looked at what that looks like on the client. So back here we've got products.gql and we've got our update GitHub integration mutation. But then once this is called or invoked inside of configure integration modal, so we're saying update GitHub integration, that's going to send the data to this, and then that's going to communicate it back to the server. So that's when we hit this. So now we're saying this is the definition. And this is just saying here are the arguments that we expect, and then here's the shape of the data or the type of the data that we expect to be returned from this mutation once all the work is done. So we'll come back to that part. But the thing to know is, okay, we've defined this, and now in order for this to work, what we need to do is actually define the mutation resolver. So remember in GraphQL, you have a few different moving parts here. So this part is just us creating the possibility in the schema for this mutation to be called. So if I were to comment this out or get rid of this, what would happen is the GraphQL API, when I tried to call this, it would say, I don't know what that is, even though we've got the mutation function defined. And so that puts us in a situation where you might ask, like, well, why do we want to do that? What's the significance of that? Or you might say, like, isn't that just more work? And like, yes, technically it is, but what it's doing is it's allowing us to definitively state what are the arguments, so what is the inbound data coming into this resolver, as well as what's the outbound data definitively. So if for some reason the data that we take in doesn't match what we specified here as the arguments, GraphQL will block the request. It'll throw an error. Same thing going backwards. So going backwards, what it'll do is it'll just omit any data that doesn't match this type GitHub integration. So what that's affording us is basically saying, okay, even if we make a mistake in terms of the data we're returning or the data that we're sending in, GraphQL is kind of like the parent slapping us on the wrist, like, hey, that's not what you said you were doing, versus just a vanilla REST endpoint or something like that. We would be in the position where we'd have to write our own authentication and logic, or not authentication, but our own schema for that and validation for that. That's the word I'm looking for. So this is saving us that trouble. So this says, here's the possible field, update GitHub integration, and then here are the values that we're allowed to pass. Here's the shape of the data or the type of the data that we expect in return. So in order to actually fulfill that, or the word we keep talking about, resolve that, what's going on is down here in the mutation, and this is, you'll notice we're in the resolvers object. So this is overall, this is our GraphQL schema. We have our resolvers object, which defines the actual resolver functions. So down here I've got I think I put this in product mutations. So all this is doing is it's expecting product mutations to be an object with multiple functions defined on it. And we're using the ES6 spread operator to say, take that object and unpack its contents onto this mutation object. And so if we go over to our mutations file, you can see here we've got all kinds of stuff. So again, yeah, this is the product mutations file. So I've got a bunch of other stuff in here, but the important one is we've got update GitHub integration. And you'll notice that it's quite simple. So just like I've been showing you quite a bit, one of my favorite things to do to keep code both encapsulated and easy to maintain and easy to test is to use the action pattern. So that's when we have a file that has multiple functions defined in it that are called in sequence. So that's, an action is basically a group of related steps that need to be called in order to perform an action. So again, in this case, our action is we're updating our GitHub integration, but we know as the developers that that involves multiple steps. So an action allows us to very cleanly or tidily organize that code into a process. So if we have to either debug it or test it or extend it later if we want to add more functionality, it makes it really easy and predictable for us. So what we're going to do is jump into this update GitHub integration action. And there's a little bit of action going on here. It's not as bad as when we had to do the repository fetching with the pagination in part 2. This is a little bit simpler. So what's going on in here? Let's go back down to the main handler function here. So the handler function, this is just what I call the function that calls all of the steps for us. So down here what we're doing is we have to get some information about what's going on. So the first thing is we need to get the existing GitHub integration. And that's going to tell us both, well, what is the current state of the integration? Because remember, we're trying to update it. So we're saying, what's the current state of it? But it's also giving us access to the access tokens. Or the access token. So the access token is the key that we pass over to GitHub in order to make the request on behalf of the user. So that's what this line is doing. It's saying, get that existing GitHub integration out of the database as well as all the configuration data for that that doesn't come out. Give us the configuration data for that GitHub integration. There we go. So again, we've got access token and we've got all of our actual configuration settings. So once we have that, the next thing is to check if we're enabling the hook. Now this is super, super important. And this was relatively frustrating to figure out because what I realized is there are different permutations that decide whether or not we're actually going to enable this hook. So back in the browser, we have two different options here. So we have sync commit mentions on cards, close cards via commit mention. So if either of these are checked, that means that a webhook has to exist in order for those to work. And same exact thing, if neither of those are checked, the webhook shouldn't exist. We shouldn't be receiving events for this specific repo. So that's what this is doing. It's saying check if we're enabling the hook. So it's trying to tell us, is it already enabled and do we need to enable it? So here we're saying allow close via commit is true or sync commit mentions is true. That means yes, we're trying to enable it. And obviously the opposite if neither of those is true or they're set to false. So like right now this would be false, so we would say no, we're not enabling the hook. So back down here, if we see that we're getting an existing GitHub integration, meaning the user has connected to GitHub and there's something to actually do here, which technically we should never bump into, but if somebody got curious and started talking to the GraphQL API directly, we would want to block any communication out to GitHub because we wouldn't have an access token or any way to actually communicate to GitHub. So this is just a safety precaution. So we're saying if we have that, the next thing we need to do is get a connection to OctoKit. And you'll remember this from part 2. So in part 2, we had to get a connection to OctoKit in order to make requests to the GitHub API. So OctoKit is a wrapper library around the GitHub API. The translation of that would be it's making it simpler for us to make requests to the GitHub API instead of performing vanilla HTTP requests. So back down here, we've got our connection. And you'll notice, let's make sure that's clear, the way that I set this up is that OctoKit is a variable that's scoped to the entire file. So at the top, I've created an empty variable called OctoKit, and then when we go to get that connection, I assign the connection back to that variable. So what that allows us to do or avoid is passing around that connection to all the different functions inside of this file. We can just scope it at the top, and then we can get access to it from wherever we are, which is nice. Makes it a lot cleaner in terms of the code and the arguments that we're passing. So once we have that, we'll notice that we've got set hook on repo. And we take in our existing GitHub integration as well as all the other options. And the options are things like the product ID and the repo that we selected and the branch that we selected and all of that information. So we're combining that with is enabling hook. So again, this function's result right here. We're saying, are we turning the hook on or not? And so if we go and look at that function, this one is quite a doozy. This has a lot of logic in it. So I'm going to do my best to walk you through this. This took about 2 days to reason myself through. So what we're doing is we're trying to figure out, well, what work needs to be done on the GitHub side of things? So what requests do we need to make to GitHub? So the first task is to figure out, like, well, what are the different variants here? What are the different scenarios? Better way to say that. So we're saying if the hook is being enabled, if it's being disabled, if we're changing the repo, and if we're enabled, meaning the hook is enabled but we're changing the repo to something else. So all of this logic is trying to figure that out based on the parameters that we pass. So we're saying if there's not a webhook ID on the integration and option is enabling hook, that means that we're turning the webhook back on. So we're under the assumption that it doesn't exist, meaning we haven't created the hook on GitHub, but we need to create it. So that's what this is saying. It's like if the hook is being enabled, we're going to create it. Conversely, the next one is saying if there is an existing webhook ID and we're saying we're not enabling the hook, so meaning it's false, that means we're trying to remove an existing hook. So we also have to keep in mind that we're not always going to be just setting this for the first time. We might want to disable it if we changed our mind, or maybe we just want to get rid of the GitHub integration entirely. So there's that case. Then we've got, are they changing the repo? So this is, do they have an existing webhook ID, and do they have an existing repo set that does not equal the ID of the repo that we've been passed from the client? So if that's true, that tells us, okay, they're changing repos, which means we're going to move the webhook from the current repo over to whatever the new one is. And then we've got this funky one, which is enabled but changing repo. So this means, okay, we have the webhook ID and we are enabling the hook for the first time and we're changing the repo. So this is probably, I think this was the hardest one to figure out, but this is helping me to figure out, okay, when that hook ID is enabled and we have an existing one, okay, that means that we have the hook already existing on one repo, but we're going to change the repo out. So we don't want to get rid of the webhook entirely, we're just going to put it somewhere else. And so the next step is the actual work. So based on that logic, we're going to make a request to octokit.repos.createHook. And this is just all of the basic configuration for this request. So this I figured out via the OctoKit docs. All I had to say was, well, I know that I want to create a hook, or down here I've got delete hook as well. So based on those, I just looked at the docs and said, like, well, what are the params that I need to pass? And if you've ever done any API work, you'll know that it's kind of a toss-up. Some APIs are really well documented, while others are kind of confusing. Fortunately, the GitHub one is pretty painless. There was zero effort into the thinking here. I just went through the docs and said, okay, what does it need from me in order for me to make this request? That was it. So what we're doing is we're saying if the hook is being enabled, so again for the first time we don't have an existing hook, or it's already enabled but we're changing the repo, what we need to do is go and create that hook. So keep in mind, and we'll see this down below, but if it's enabled but we're changing the repo, we're doing two tasks at once, which are, first we need to set the hook on the new repo, but then we need to get rid of it on the old repo. So keep that in mind for a sec. So if the hook is being enabled, or we're moving to a new repo, we want to set the hook on whatever that repo is. And so we pass the repo here, which is just the name of it. So in this case, this is going to be test-github-webhooks. And then we're saying the owner. So in this case, I am pretty sure I'm authenticated, yeah, as the Clever Beagle GitHub account. So that's what's being passed here is Clever Beagle, all one word lowercase, or the username for the account. And then we've got the configuration. So we're saying, and this is the configuration for the webhook that we're creating. So we're saying, okay, the URL is going to be, if we're in development, I'm setting it to my ngrok server. So if you've never heard of ngrok is a tool for opening up a internet accessible tunnel back to your local host or back to your local machine. So technically what this is doing is it's creating a URL that's exposed to the internet that can then forward requests back to my local machine. And so this is saying, if we're in development mode, any webhooks that GitHub sends us, I want them to go to this URL. And when they get to that URL, the service that I'm using, ngrok, is going to forward those to my running instance of their tool on my computer. So basically it's just going to forward the request from their server down to my localhost port 3000, which is awesome. So that's in development mode. And then if we're in production or staging, what we're going to do is we're going to say we want to get the current running URL for the application with meteor.absolute URL. So if I'm on localhost 3000, this is going to come back as http localhost 3000/webhooks/github. And thinking the same exact way, if I was in production, so the ultimate version of this app is going to live at app.oncommand.io. So this would be app.oncommand.io/webhooks/github. That's it. So that's literally saying where should GitHub send data, like what is the webhook that we're creating. And then we're saying, okay, we want the content type that they send to us to be JSON data, so it's easily parsed. And then we have our secret. So this secret is actually a neat feature. I didn't know this existed. So what this is doing is it's allowing us to create a hash value that we can authenticate our requests against. So what GitHub does is they take this secret, and I want to say they do a hmax SHA-1 hash of the data that they're sending you along with the secret or using this secret. So now when I get a webhook back from GitHub, what I'm going to be able to do is say, okay, and we're going to look at this. This will probably come in, we'll do like one more video here for this series, but what that's going to allow us to do is confirm that the data we're getting is actually something intended for us. And the reason why we have to do that is that a webhook is publicly exposed, meaning this URL is going to be always available or always open technically to the public. So any data that's sent to it, we need to validate that it's actually what we expect so somebody doesn't do something malicious with it. And so that's what we're doing with this secret is we're telling GitHub, use this secret to confirm later that this data is actually authentic or it's coming from GitHub like we expect. And the very last piece of this is that we have different events. So the point of a webhook is that we're trying to say, when this happens, tell us about it. And so in the context of the different hooks that we're enabling, so again, these two, sync commit mentions and close cards via commit mentions, we need to know whenever somebody has mentioned a card number inside of a push, so you've pushed code from your computer to GitHub, or if you've created a pull request and you're mentioning that card or trying to close something via that card. So whenever those two events happen, we want to know about them. And so that's what we're saying here. And GitHub has a huge friggin' list of all the different events that you can get. So these are just two of them. But literally any activity that they detect, they can send you an event for it as long as you specify it here. It's pretty cool. So once all of that is done, you'll notice that what I'm getting here is I get a response back. So I get the hook, and then down on this line I'm saying, okay, give me the hook ID. So that's the important part for us. That tells us which hook is actually enabled and what are we working with here. So once we have that, then what we're doing is we're saying take that hook ID if it exists and set it on the product. So we pass the product ID from the client along with the hook ID, and then back right here we say update our product, setting the integrations.github.webhook ID property to that hook ID. Simple as that. So that tells us, okay, we've created a connection to GitHub, we've created the webhook. That's it. That's all we need to know. So the other side of this is if we're not creating a webhook for the first time, but we're trying to remove it in some way. So remove it in some way is through two variations. So again, we've got explicit, which is we're disabling the hook permanently. We're not moving it to a new repo. We're not doing anything. We've literally checked both of these off and we want to get rid of it. We're done with it. So that's one case. And then the other is if we're switching from one repo, meaning we're switching the hook from one repo to another. And so when we do that, what we're trying to say is, okay, if I'm moving from repo A to repo B, and repo A already has a hook defined on it, I need to delete repo A's hook because we don't want two for no reason. If the user hasn't told us that they want to watch repo A anymore, there's no point in receiving events for it. So we want to delete that hook. And you'll notice up here, that's what this whole part was about. So we're going to remove it from A, and then up here we're saying set it on B. That's it. So the deletion process is pretty simple. So it looks pretty similar to creating a hook, except there's just less configuration information. So we need to know, well, what is the repo? So again, this is going to be test GitHub webhooks. And we need to know who's the owner, so Clever Beagle in this case. And then we need hook ID. So hook ID is the existing webhook ID that we just set back here. So when we create it, we set it on the product at this position on the product's integrations objects. We're saying integrations GitHub webhook ID, set that to the ID of the hook. So when we go to delete one of these, what we need to do is pull back that ID, because again, this case is only going to fire if this already exists. So if it does exist, we want to go ahead and pass that hook ID back to GitHub to say, hey, get rid of that, you don't need it. And then the very last part of this is the hook being disabled? So when this is true, we need to unset the hook ID on the product as well. And notice I'm not saying if hook is being disabled or is enabled but changing repo. I'm saying only if the hook is being completely disabled, meaning you're removing it permanently. So if that's true, then we don't want to store that in the database anymore. And that does a few things. One, it just avoids us having stale data around, but two, it also removes any potential for us for receiving webhooks or anything like that from the user. So it makes it completely clear and basically resets the webhook status back to nil or null. So if we look at that function, all it's doing is using, in this case I'm using MongoDB, so this is unsetting that property on the GitHub integration. And so once all of that's done, we're going to come back up to this. If we jump back down here, and again, this is the main handler function that's calling all of these steps. So at this point, we've just completed set hook on repo. The very last part of this is that we need to update the integration on the product. So remember that we're not just sending information about the hook that we're trying to create, meaning which repo are we trying to set this on. We're also sending information about what we should do internally when we get one of those hooks. So that means we're trying to set this value, and we also want to keep track of repository and branch ourselves. So we need to make sure that those actually exist. So what we're doing here is we're saying update the integration on the product, and we just take in the various values that we passed from the client. So we're saying take in the product ID, the repo, the branch, and the two toggle options, and then we're just setting those on the integrations.github object in the database. Simple as that. So that's it. So that gets us to the point where now we've actually stored this in the database and we have an actual connection to GitHub. And if we play with this, so we're going to go back here and refresh this, and you'll notice that I've got the Webhooks tab open for this test GitHub Webhooks project. So right now we don't have anything. And if we go back to our UI and look at our configuration, we do have test GitHub Webhooks set as our repo, but we don't have either of these enabled. So what I'm going to do is say, let's go ahead and sync commit mentions on cards. So I'm going to save the integration. And again, we have to make that hop to GitHub, so it takes a few seconds. And once we've got it, we say it's updated. And if we jump back over here, we can see that our hook exists. And then if we go back and we say, like, you know what, we changed our mind, we're going to turn it off, and we save it. Now if we come back in here, webhook's gone. So same idea, if I turn on both of these, what's going to happen? So keep in mind, GitHub doesn't have any concept of these two ideas. That's for us. So if either of them are checked, we're going to set a webhook, and if neither of them are checked, we're going to remove it. So right now, I checked both, but we only have one webhook because it's always going to send us messages or events from this repo, and then internally inside of command, that's up to the logic or the code to decide, okay, what are we doing with this information? So there's that. And then conversely, what we can do, and let's see, well, I'm trying to think of which repo I can put us on here that's not going to break something. Let's do it. We're going to do it on the Clever Beagle app. So this is used with customers at Clever Beagle. So I'm going to put this on the master branch. That's fine. It's not going to hurt anything. So we're going to go ahead and save that. Now keep in mind, at this point, we had the webhook for these two already enabled. So I'm going to refresh this. It's not working. I might have a bug here. Let's see. Did I get a bug in my console? I didn't. I wonder why. So let's try that again. We're going to flip to app.cleverbeagle. We're going to set the branch to master. And we're going to save. We might have a client-side error. Let's see what we're getting. We do. Hook already exists on this repository. Okay. So this is not a fault of the current code that I walked you through. This is my test data is out of sync. So back in the app, because I was testing moving between repos before on my other computer, so that's why this isn't working. If we go to settings and we go to webhooks, sure enough, I left it on here. So we're going to delete that. And then we go to login, jump through hoops. Okay, so that's deleted. So now let's refresh this and see if we can get this jamming. So if we go here, okay, so we're on test GitHub webhooks, and we're going to flip to app.cleverbeagle, go to the master branch, save the integration. Looks like that time it took. Okay, so now we flip to this repo, so we should see it come back, and we do. And then let's jump to another tab here and make sure that I didn't break our testing webhooks. So we'll go here, go to settings, go to webhooks, and it's gone. So that checks out. So if we run through that again a little smoother. So right now, app.cleverbeagle.com has the hook. So we got to refresh there. Okay, so this definitely has it. This doesn't. So let's flip to this repo and see it flip-flop between the two. So if we jump down here and we go to test GitHub webhooks, so we're switching to this repo from app.cleverbeagle. So I'm going to save this. Okay, that's updated. So now back over here, this is where it was, so it should be gone here. Good. And it should show up here. Beautiful. So there we have it. So that is enabling the integration and updating the integration and doing all kinds of stuff. So that's pretty cool. That's a lot of work done, but we're still not finished with our integration because at this point we've told GitHub that we want events and we've recorded all this information in our database, but now we have to answer the question, well, how do we actually integrate with GitHub? Meaning, what happens when they send us one of those events? So what we're going to do next week is take a look at that process and kind of walk through what does it look like to ingest a webhook and how do we authenticate that and do all that stuff, but also how do we make use of that inside of command directly. So that'll be the exciting part. So right now we've just been doing boring configuration stuff, but now we'll actually get a look at, well, how does that influence or affect the actual application when we get that data from GitHub. So we'll take a look at that next week. So that's going to do it for me. As always, if you haven't already, make sure to click the button down below to subscribe or hit the bell just to the side of it to get notifications as soon as these are published. And as always, send me tweets if you have ideas for different episodes that you like to see or things that you'd like to have a walkthrough in the future. And also just if you have any questions. So if you're watching these and you get confused or anything like that, you can always leave questions below or just send me a tweet or an email and I'd be happy to help you out. So signing off for the HMS Beagle, and I'll see you next week. You just listened to me run my mouth for the better part of an hour about a bunch of really technical code. So why not commemorate that experience by watching another tutorial and having an absolute psychological meltdown?